This morning's project is going to be some automatic bumpers that seem to pop up randomly on their own. What I ended up doing is I pulled this plug out. This is the extension line that runs to the jam switch on the swing plate over there. I did meter that, and it came up with like 11.3 ohms. And to me that seems a little bit high, but I don't think that that's our issue. I metered this leg on this switch. Let me see if I can zoom in a little bit, if that's not too much. This leg on this switch has continuity to ground, and I don't think that it should. So we're gonna go ahead, we're gonna take out our zip tie right there and inspect our wiring a little bit closer. Let me make a correction. It is the red wire on this jam switch. This red wire has continuity to ground. I may have made a very careless mistake in my initial diagnosis. I may not have been probing that leg properly. I may have been touching the meter lead to the motor swing plate to ground, right? So maybe I misdiagnosed that due to some careless activities. So let's take a closer look at this circuit, even though maybe I didn't meter it properly. From the cable, from the bumper box, we've got black and red that make up your jam switch circuit out of the cable. The black lead goes to this plug, goes to the black wire there, and then travels all the way to that switch. When the switch is closed, it comes back on the red wire. That red wire goes back into the plug and goes on white up to here. Then the other side of the switch is red, and that's your path back. So we have two switches that work in series. Both of them have to be closed in order for the bumpers to operate normally. If either one of those switches opens, it detects an issue. It detects an open circuit, and it pops the bumpers up into what we would call on the Brunswick scoring system emergency up. And that's what we're having. We're seeing the bumpers randomly pop emergency up. This switch, I metered this switch, 0.2 ohms. I didn't get it on camera because I don't have a camera mount, and we're just kind of winging this on the fly. But we noticed earlier we've got 11.2 ohms of resistance on that switch to the opposite side of the lane. And I'm wondering if that switch might be going bad. I've manually manipulated the bumper rails so that the swing plates swing and the jam switches are opening and closing. And I did that a couple of times, and now my resistance is at 74.8 ohms. So that's way too high. So the fun part is we have to take the capping off in order to get the gutter out. So this turns into a bigger project than we had initially thought, but we have some time this morning before we open, so this is good. Well, this is interesting. Let's see if I can get it in frame. I'm metering right on the switch legs. .1, 0.2 ohms. So that leads me to believe that we have an issue with our cable here. What I'm going to do, I'm going to cut the wires back, and I'm going to put new terminal ends in, and then we're going to retest ohms. We're going to check ohms on the other side, the plug end of the cable, and hopefully we see that go back down to 1 ohm or less. I didn't have any fully insulated wire terminals, but that's okay. I'm not super worried about it. What we're really looking for here is that it's going to function and it's going to test okay. We don't have a lot of voltage going through this wire, so I'm not really worried about it arcing to ground or the frame. We just basically reference voltage. I think we got it. We're metering 0.3 ohms at the plug end over here, where we were getting a much higher reading before. So I think that the wire terminal ends, the crimps in there have maybe failed, or they weren't crimped sufficiently from the factory. This is the first time we've been in here, so I know that no one else has done any work on these before. These are still factory fresh. But anyways, that's gonna do it. We should be able to button this thing back up, and our mysterious emergency up bumpers will no longer be an issue.